Thanks. Hey, everybody. So as Jason says, this is a talk about UniPro. It's a software-motivated talk, since that's what I can talk about. And we'll kind of talk about why we picked UniPro, what its key features and non-features are, and how it's going to tie together into the rest of the software stack. So let's start at the hardware. You've seen the interface block in Spiral 2 before. The UniPro pins are on the left. There are a variety of other pins that do have software impact. They're not going to be discussed here, but the documentation in the MDK will fill in any blanks. OK, so why do we pick UniPro? Because it's easy to use. It has very familiar high-level semantics if you're used to networking, either internet or otherwise. You can send and receive arbitrary messages of arbitrary size with guaranteed in-order delivery. Underlying this simplicity, however, are sophisticated underpinnings. It is a very mature technology stack. It's been iterated in the standards body that defines it, MIPI, for several versions. As Ara said, it's got great electrical characteristics. And it also has a variety of quality of service features and low latency that really matter a lot to us in software. It is a mobile-friendly basis for other kinds of peripheral communication that we commonly see in mobile. So there are a couple of protocols already that are based on UniPro, which provide support for cameras and flash storage devices. So those are respectively CSI3 for cameras and UFS for flash storage devices. They're based on UniPro, UniPro at the core, and obviously very important mobile use cases. OK, so this is the 10,000 level view, 10,000-foot view of UniPro and how it fits into Project Ara and what it gets us. We know there's a UniPro switch in the endo. We know we can get bidirectional connections for data transfer. You can establish multiple connections between modules, and any pair of modules can have these connections. The way this works in terms of the interface block is that at each interface block, there is a UniPro port. The UniPro switch has a corresponding port, which is blocked out on the endo. And the network is packet switched. So every port has a device ID. When you want to send a packet from one module to another, you embed the device ID in the packet. That tells you where it's going. Now, there's multiple connections possible between a pair of modules. So you also embed within each packet a destination CPort ID. And so that allows the receiver to identify which connection a received packet is associated with. And that plus payload and some other control information is what you'll see on the wire. OK, so here are some key features and non-features. I wanted to include some of these non-features because it's something that I've run into a lot when talking to people about UniPro. So we've seen reliable in-order transmission of datagrams. We have credit-based flow control. So each side exchanges credits to let the other know how much buffer space is available. And that lets us avoid buffer overruns without saturating the link with too many retransmissions. We have 2 levels of traffic prioritization. And the reason why those exist are to allow us to have high-priority small messages preempt the middle of a larger, lower-priority message. Now, the non-features that I want to highlight here are no stream transmission. So it's datagrams only, and no multicast. You must establish a connection between 2 modules exactly. 3 modules cannot share a CPort, basically. In terms of its structure, UniPro is strictly layered according to the OSI 7-layer model. And the scope of the definition of the UniPro specification is from above the physical layer up to the transport layer. So the transport layer is what gives you the datagram transmission. And anything above the transport layer is not defined as part of UniPro. So CSI3, that camera protocol that I mentioned earlier, is built on top of UniPro, and that's a layer 5 and up protocol. Now, there are a variety of other things than cameras and storage devices in your phone, right? And we're going to be building them for Project Ara. So we need protocols to get that information between them and the other modules. And you'll hear a lot more about those protocols later on. OK, so that's UniPro. That's why we chose it. That's why it's so great. How do I use it? The last time that we were here for DevCon 1, it was all on an FPGA. And I'm glad to announce that now we have ASICs, both in development and here in the room right now. So something that's in the works, we'll start with what's in the works, and then we'll move on to what we have now. Something that's in the works is a native UniPro processor. And so that means that the UniPro peripheral is integrated directly into the die with the processor. You can see the block diagram here. And if you've ever seen a mobile SoC block diagram, they tend to be a lot more complicated. This is actually pretty simple, and that's something that is enabled by the fact that the endoskeleton is the communication bus between all the modules. All you really need on the AP module is a little bit of memory, something for flash storage, the cores themselves, graphics, and associated things that have to be on the die for latency and throughput reasons, and then just a bunch of ways to talk to the UniPro network. We have CSI3 and UFS that I mentioned before. We have a couple of bridges for some legacy camera and data protocols that I'll discuss a little bit more later. And then we have a bunch of CPorts. And that's it. Also in development, we've got some CSI3-based cameras and some UFS-based flash storage devices. And you'll hear a lot more about those in future talks. OK, so what have we got right now? You've heard a little bit about these two Toshiba ASICs. There's one that is designed to interoperate with existing lower throughput protocols. And Ara kind of introduced what's inside it during the Q&A that preceded my talk. So there's a microcontroller that has a bunch of standard peripherals connected to it. So things like a serial port, SPI, stuff that you're very familiar with if you're a mobile developer. And it also has a UniPro port. And so its purpose is to bring up things like Bluetooth and baseband modules and GPS and stuff that speaks these existing protocols and translate them to UniPro. But it also enables new things. It's very general purpose. You can program it however you want. And so you can come up with your own designs. Now, I mentioned that there were a couple of special cases for existing legacy camera and display protocols. There's another ASIC that we've developed that kind of handles these special cases. So these are shown in the top right, CSI2 and DSI1. And those are camera and display protocols and PHYs that use a different physical layer than UniPro. And because these are high throughput and necessary, we decided to go ahead and build a special ASIC for handling these directly in hardware. So this high-speed ASIC routes camera and display traffic through to UniPro entirely in hardware. And the AP will send it on one end. It'll get translated, shipped over UniPro, and brought out on the other side. And so that's why that native UniPro AP had those existing IP blocks, specifically for this purpose. OK, it also has a USB port. And you'll see why in a bit more detail in a later slide. Basically, what this is for is to let the existing SoCs out there that don't have native UniPro ports get on the network. So they can talk to the microcontroller that's on this ASIC through the USB port and have CPort traffic directed from there. OK, this is a block diagram of the prototype system. You can see the AP on the left with the display and camera protocols that go through to hardware, and also a few other CPorts through USB. And you'll see that they get routed through the switch, and they pop out on the other side, also through the bridge ASICs. This is an example of an objective system. Of course, there's no one system. This is just one example that has a native UniPro AP, a UFS flash storage device, a CSI3 camera. So these are native UniPro peripherals. And it also has some other modules that still have bridge ASICs. So it is a project-level goal that we're going to have interoperability between these native UniPro peripherals and designs using bridge ASICs. OK, so how do we power these bridge ASICs? Well, with firmware. And we're going to be releasing a bunch of firmware that has helper libraries, reference firmware for the demonstration modules that Dexter was talking about, and all this other stuff as open source software this week. Patches are totally welcome. This firmware will be useful on the development hardware. What does it include? Well, it has RTOS support. We picked an RTOS. You can choose your own, of course. It has a core library for dealing with UniPro. And it has some implementations for these application-specific higher-level protocols, both to bridge things like serial port traffic over the network, over the UniPro network, and also higher-level protocols for things like displays and touch panels. It's common stuff that you'll find on a mobile device. You can find out a lot more on projectara.com. In particular, there was a really great talk on UniPro in DevCon 1 that went into a lot of details by the chair of the UniPro working group. And there's a bunch of other topics that I unfortunately didn't have time to cover here. All the technical details are spelled out in the MDK, in the UniPro specification, and in the reference materials for the ASICs.